You guys want to know something epic? USACO results are out. Isn't that crazy? Hopefully you guys did okay, but now it's time to gut through the Livesolve. So let's get into it, okay? Hello everybody, I'm Carrara, and today we are going to be doing the bronze Livesolve in Python because I do not want to do the silver one in Python. No, still triggered from last time where I converted my Python code to C++ and then suddenly it stopped timing out. God dang it. So we're going to use Python for this, and we're going to use C++ for silver, hopefully. Let's do it. I'm sorry, I'm not going to do Java anymore because honestly speaking, if you know Java, you might as well switch to C++. It's exactly the same, except C++ is just superior. There's like no question about it. Alright, let's get started with the first question. Okay. A little known fact about cows is that they have their own version of the alphabet called the calphabet. Oh my god. It consists of 26 letters A through Z, okay? But when they speak in calphabet, she lists these letters in a specific ordering that might be different from the order, okay? So she's been humming, okay. So Farmer John hears a certain string, and then the minimum times Bessie must have hummed the entire alphabet in order for what? I don't completely get this, okay? So Bessie, so he might have missed some of the letters, okay? So minimum number of times, okay? The string you are told consists of just the letters that he remembers hearing, okay? Okay, so they give us the order that it should be, right? So essentially it doesn't even matter, we just have the order at the beginning. And then the next line is what he hears Bessie say, okay? And it has a length 1 and at most 1000. Okay, so basically the minimum number of times is if you have like M and then O, right? Like that could still be part of the same alphabet, right? Because over here M is before O, so it could still be in the same alphabet, but once you say another O, you know she must have gone through the alphabet twice at least, right? Because you can't get back to O without starting it again, right? And then because D is before O in the alphabet, we know we have to start again in order to get back to D from O, so that's why it's 3. Okay, so that makes sense. Let's code this boy up. Call it calphabet because I like that word. Alright, so it's just stood in, right? So all we gotta do is alphabet is equal to input and S is equal to input, okay. And now we basically need to have like a reverse mapping to index, right? So let's say we see the letter M, that is like index, whatever index this is, right? And then we have O, and then we see that O is this number. So eventually we're gonna reverse the alphabet, right? We have a letter, and we want to get what number in the array it is. So to do that, we'll just have reverse is a dictionary, and then for C in alphabet, reverse, well, we should probably do for I in len, I in range len alphabet. And then we'll just set reverse of alphabet I to equal I, okay. Okay, so now we just go through S, and then if okay, so we'll keep track of our current index, right? So we'll say car is equal to 0, or equal to -1, I guess. And then if the next letter is greater than the index, we don't need to restart our alphabet. But if it's less than or equal to the index, that means we have to restart the alphabet, so our count increases. So count is how many alphabets we've gone through. And then we just do for I or C in S. If reverse C is greater than or less than or equal to car, then we want to do then we want to do count plus plus equal 1, okay? Otherwise, we just set car is equal to reverse C, okay? And then at the very end, we just print count. All right, let's try this. Okay, so, well, it should start at 1. It should start at 1 because we know that it for sure has to get through the alphabet once. Could the string be size 0? Okay, at least has 1, so it for sure has to be at least 1, so that would make sense. Alright, so let's try this. Alright, a moment of truth. It better work, otherwise I'm going to be very sad. Hey, okay. Very epic stuff. Now we move on to number 2. Even more odd photos array. I love odd photos. Farmer John is yet again trying to take a photograph of his N cows. Wow, each cow has an integer breed ID, okay? And has a very peculiar idea in mind for his photo. He wants to partition all the cows into disjoint groups, okay? Place each cow in exactly one group, and then line up the groups so that the sum of the breed IDs of the cow in the first group is even. The heck? The sum of the IDs in the second group is odd, and so forth, okay? What are the maximum possible groups he can form? Okay, this seems annoying. Let's see. So the first line of input contains n, the next line contains n, space-separated integers giving the breed ID. Okay, so the actual breed ID of the cow doesn't even matter. You just care whether the breed ID is odd or even, okay? So what is the maximum number of groups in Farmer John's photo? Okay, well, yeah, I'm sure that's true. So, first group has to be even. So, even basically means you either have an even number of wait, what? uh, okay, so even means you have an even number of, like, you have only even cows, or you have, well, no, the only restriction is that you have an even number of odd cows in that group, okay? And then the only restriction, okay, and then the only restriction for odd groups is that you have an odd number of odd cows. Okay, so essentially, like, the even cows don't matter at all, right? Like, you could always put one even cow per, like, even group, so the even groups don't matter. The only thing that matters is the odd group. And we know that, like, odd cows, we want to put them in different groups as much as possible. Although if you have no even cows, then you have to start pairing odd cows together. Okay, so essentially, so basically the steps are, first you put all the even cows down in the even groups, right? And then once you have, like, the number of even groups you can make, then you just want to find out how many odds. Or actually, you first find out how many odd groups you can make, and then you assume you can make all the even ones. Is that what you do? Okay, why don't you just start from the beginning, right? So the first guy, you have, like, let's say you have, like, n, or let's say you have, like, 5 odds and 4 even, then you go to the first group, right? So then you put an even there, because it's an even group, you might as well use even there. Then you go to the next one, you take an odd, you go to the next one, you take an even, and then if you have no even, then you put 2 odds in. If you have or 2 odds or 1 odd, depending on whether. And if you have no odds, you can't go any farther. So, okay, we'll basically just do that then. Alright, so Python, and we'll call this photos. Alright, so we do n is equal to int of input, and then we do nums is equal to input dot script dot split by space, and then we will map an int to all these boys. Okay, so now we got all the ints in our epic numbers array. Alright. And now we just want to check how many evens and how many odds there are. So we'll have evens is equal to 0, odds is equal to 0, for I in range, or I in nums. If I mod 2 is equal to 0, then we do evens plus equal 1. Otherwise, we do odds plus equal 1. So now we have the number of evens and odds, so we'll just go through it and we'll say for, or we could do I is equal to 0, and then, what should we do? Should we just do, like, while we have more odds, we could always, okay, let's say while odds is greater than 0. So, if I mod 2 equals 0, which means it's even, then we just want to take an even if there is an even. So, if evens is greater than 0, then we just evens minus equal 1, I plus equals 1, okay? And then we continue. Otherwise, what do we want to do? If there are no evens, then we have to put 2 odds. So if odds is what? So it's an even one, and if we only have 1 odd, what do we do? Well, if you have 1 odd, then you're, like, kind of doomed, right? Because all your previous ones are odds and evens. Let's think. So if you only have 1 odd left, okay, so let's say if odds is greater than 1, right, then we could just put 2 odds here. So we do odds minus equal 1, I plus equals 1, or we could do I plus equals 1 at the top, so that we don't have to do it in each thing. So odds minus equals 1, and then continue. But then if it's 1, what do you have to do? So you have to put in a previous one, but then you're doomed, right? So right now you're at even 1. Then you have to basically get rid of the previous odd one. And then if you just do that, then you should be fine. So you put it in the previous odd one and move everything to the next even one. So you'd have to do I minus equals 2, right? Oh, we have to do minus equals 2. Okay, here. And then if it is 1, then we have to do I minus equals 2. We might have fixed this a bit later, but that is fine. Otherwise, if it's odd, then we can't use any evens here, that doesn't even matter, so we'll just do odds minus equals 1, that's the only option, we have to put an odd there, and then we should be good. And then we just print I, okay. So how would this work? Let's see. Okay, so it goes here, right? And, okay, so we only have, how many odds? So we have 7 odds, right? So it'll go to the first one, it'll have to take 2 odds, right? Because odds is greater than 1, it'll take 2 odds, then it'll take 2 odds, so now I is 2, then it'll take 2 odds, now I is 3. Okay, so it takes 2 odds, so now I is 1, then it goes 2, and then takes 2 more, so now odds is 3, then it goes again, so now I is 3, and odds is 1 now, after this, then it goes 4. So okay, so it takes 2, and then it takes 1, then it takes 2, and then it takes 1, and then for the next time around, it's on an even 1. Yeah, so it's on an even 1, and then it goes here, it'll eventually get to here. So this is I equal to 4, right? So then why does it print out 1? Let's just print out I over here. Oh, this should be over here. Okay, there we go. That makes a bit more sense. Oh, no, what? Yeah, let's do that. Okay, that would make a bit more sense. Okay, so now it goes to 4. Why don't we just put this here, and then we could do equal 1 here. Oops, we don't want that. Oh, so then here we want to break. Okay. Yes, that would make a bit more sense. Okay. Because if we ever run out of odds, that means we're done. So that should be fine. Okay, so we basically end up with 7 odds, then we use 5, then we go 4, then we go 2, then we go 1, and then it gets to 3. Alright, that seems legit. Okay, so why don't we just do 4 odds, right? Then essentially on the only way to do 4 odds is to put all of them in the first even spot. Yeah, so it should be only 1. So 1, 3, 5, 7. And it gives you 1. Very good. Okay, I think this should work. Let's see if it works on the other test case though. Hey, it works. Okay, let's try this out. Basically, the main idea is like you just try putting in as little as you can to make the first 3 groups, and then if you end up with like 1 odd at the end, then you know that like the odd has to fit in somewhere into somewhere, but then it's gonna change the parity, so you can't even have the last 2 groups. All right, so far so not good. God dang it! Wait, let me think this through properly. Hold up. Probably not the smartest way to do this. Okay, so in the first group, you want to put an even or 2 odds, right? That's the only way to do it. Okay, I think the only thing that I'm not sure about is like what happens if you have extra odds? Is there ever a reason why you could still have like the last few groups? There might be. Oh, if there's an even left over. Wait, no, but then that should still keep going. Oh, okay, this should be while true. Okay, that makes sense. Okay. If odds is equal to 1, then we only if it's equal to 1, then we do that. And then that should be fine. Okay, let's try this. Because basically the one case I was not thinking of is if you like end up with no odds left, but you still have an even left, then you can put the even in the last spot and it doesn't matter. Except that seems wrong. Okay, so let's go through the algorithm, right? So you basically put a 2 in the first slot, then you put a odd in the next slot. So now you have 5 odds, and then you put 2 odds, and now you have 3 odds, then you put 1 odd, then you have 2 odds, then you put another 2 odds. I feel like I'm overthinking this, god dang it. What's the right way to do this? What's the fastest way to do this? So obviously the only thing that matters is the number of evens and odds, right? Okay, so let's just say you have like 5 evens and 6 odds, right? Then you can for sure do odd, even, odd, even, odd, even, and then you'll have like some amount of odds left, and then the odds that are left could contribute to an even and then an odd, depending on whether it is bigger. Okay, so why don't we just do that? Okay, so if evens is greater than odds, then we basically just do I plus equals the number of odds, and evens minus equals odds. Okay, so now that's how many evens you have left over, right? And essentially, if you do even, odd, even, odd, even, odd, then you could basically only do plus equals 1. So if evens is greater than 0, greater than or equal to, if evens is greater than 0, that means you could add that last one, so you just do I plus equals 1. Okay, and then the other option is if they're less than, then you do I plus equals evens, and then you have like odds minus equals evens left. So that's how many odds you have left. So now you have to make an even. So you basically just do, let's see, if like, let's say odd is equal to 1, then we are done. What do we do with the odd though? Yeah, then you had to combine it with the previous one, and then you had to do minus equals 2. Or minus equals 1, sorry. Wait, odds are annoying. So, let's see. You need 3 odds to do a cycle. And then, if you have 1 left over, then you can't make the last cycle. Okay, I see. So if mod odds... Okay, so then we basically had to add like... Wait, sorry, 2 times this, and 2 times that. And then we do like I plus equals 2 times odds over 3, right? Because essentially you need 2 for the evens, then 1 for the odds, then 2 for the evens, 1 for the odd. And then if like odds mod equals 3 is, or mod 3 is equal to 1, that means we have 1 left over, then we have to do I minus equal to 1. If it's 2, then we could add 1, right? And if it's 3, you're good. So if odds mod 3 equals 2, then we do I plus equals 1, and other than that, we should be good. Okay, that seems to be working, and that seems to be working. Okay, this makes a bit more sense. I see what I did wrong the first time, but this should work. Hey, we did it, boys. Okay, very nice. Alright. That is why you should think a little bit before you actually start implementing, but let us do the third one. Let's get it. Alright, Farmer John has n cows of heights A1 to AN, okay? His barn has n stalls with maximum height limits B1 through Bn, okay? And in how many distinct ways can Farmer John arrange his cows so that each cow is in a different stall and so that the height limit is satisfied? Okay, so that seems fine. First line contains n, then it has the height of the cow, then it has the barns. Okay, so it says how many ways? How big is n? N should be tiny. Yeah, okay. Wait, okay, 20 factorial is probably too big, but oh no, we gotta use longs. Well, Python is epic, you don't need longs, that's lame. Okay, let's see. So how many ways are there to do it? So is it just like brute force? Like, could you just brute force it and then see? Okay, so why don't we sort it? What does that do? Okay, let me just bring up scratch paper. I think we might need it for this one. Okay, so you have 1, 2, 3, 4 as your height of your cows. Then we have 2, 3, 4, 4 is the height of the barns. So we could either put 2 in any of these, right? 1 can go in any of these. 3 can only go in these 3, and 4 can go in these 2. Yeah, I feel like you have to just brute force it, right? Like, I mean, but that is 20 factorial, so that might not be good. Okay, what is 20 factorial even? Is it big? I don't know how big that is. Oh, yeah, that is very big. Bruh. Huh, so if we assign the biggest guy first, right? Then it doesn't impact, like, it'll equally impact everybody below the biggest guy, right? So, okay, so this guy has 2 ways to do it. And then this guy, no matter what this guy chooses, will have 1 less way to do it because this guy will impact that. So this guy has how many options? 3 options. So now this guy will for sure have 2 options no matter what. Okay. Oh wait, that's kind of big brain. Okay, wait. I think we got it. So let's just say we have like 1, 2, 3, 5, 7, 9, 11, and then we have like 1, 2, 7. Wait, no. 1, 2, 4, 4, 4. Or no, we can't do that. It has to be possible at least. 5, 7. Wait, they're not even possible. 5, 1, 4, 5. Or we could do like 6, 6, 7, 7, or 7, or we could do 11, 11, 11. Okay, how about that? Okay, so this guy for sure has 3 options, right? Then this guy had 3 options before, but now he for sure has 2, no matter which of these 3 11 chooses. Then this guy will for sure have 1, right? Because these 2 have to choose from here. Okay. Then 5 will for sure have 4. Or 5 will for sure have 4. Yeah. And then this guy will for sure have like he originally has 5 options, but 4 people have already gone before him, so he for sure has 3 options now. Wait, what? 5 minus 4. So he should have 1. Wait, what? This guy should have 5 minus 3 options. So he should have 2 options now. Okay, yeah, because he has to do one of these 2. This guy has 1, this guy has 2, this guy has one option, yeah, and then this guy has 1 option. Okay, that makes sense. You multiply them together and you get your answer. Okay, so that was coded up. Wait, why did n have to be so small then if it's that easy? What the heck? Okay, I'll take it. I will take it. Stalling, alright. Okay, so n is equal to int of input, and then nums, or let's see, a is equal to map int input dot script dot split. I mean, the script is probably unnecessary. Let's just do dot split, and then we do map int input dot split. Although technically strip is probably a good practice in general, but I think that's fine. So we'll first sort them. So we'll do a dot sort, b dot sort, and then we'll go backwards, right? So we basically got to keep track of how many numbers there are above any given number. So How do we do that? We basically had to like lower bound it into the other one. Or we could just do 2-pointer. Wait, big brain. Okay. Let's see. Okay, yeah, we could have a 2-pointer thing, or not even a 2-pointer. We could just go backwards, right? So for I in range, start, stop. So we'll do like n minus 1, comma, like -1, comma, -1. So now it'll just basically go backwards, and we'll also have to keep track of the number, like, greater than. So, what do you call it? Let's just call it J because we like descriptive names, that is right, okay. So, nothing is greater so far. So, while, the barn for the current cow, so while the barn for the current cow is bigger than the current cow, then we could add to J. So, while, like, b n minus j minus 1 is greater than I, or AI, then we just want to do j minus, or plus plus, or greater than or equal to, plus equals 1. Okay, so now we know how many are bigger than this current cow, and we also know that I, maybe we should just do I is range n, because that is cleaner, and then we could just do n minus I minus 1 here. And then we basically have our answer, we'll say is like ants is equal to 1, and we'll multiply it by ants times equals j, right, minus the number of things that have been placed already, which is I. Minus I, and that should be right, and then we just print answer. So while j is less than n, and that, so if j is greater than n, then I'll just skip over this part. Because if it's equal to n, then this will be a negative number, and we don't want that. Everything else look good? I think it should be good, so let's test it out. Wait, if the solution is actually brute force, I'm gonna be big sad. Okay, well, list these dudes. Bro, I wish we had Vim on REPL, that would be epic. Alright, put this boy in. Indeed, 8, okay. I think this should work, unless I trolled, which is very possible, but I think we did it right. Alrighty. Hey, very nice. I don't know why I didn't show the intermediate steps, but we did it. Very epic. Alright, thank you guys all for watching. I hope it was helpful. I kind of trolled on the second one, but hopefully you guys learned something from seeing me do it. This one was actually kind of clever, I'm not gonna lie. What was the intended solution? What the heck? Was it just... Okay. Why this n squared time? Oh, okay, so yeah, they basically use the same idea, but they did O of n squared, but I did O of n. Okay, that's epic, okay? Yeah, that's pretty good. Very nice. Anyway, I just wanted to see what they did for the other one. What did they do for this one? Oh, okay, yeah, so I guess it could have been a little bit smarter and then reduce it down to the previous problem, but... Oh, yeah, okay, yeah, we could have just... Oh, okay, yeah, that makes sense, that makes sense. So I didn't have to do that many special cases, but that should be fine. Alright, well, that's the wrap. Thank you guys so much for watching. As always, if you enjoyed the video, leave a like and subscribe for more. Let me know down in the comments what you guys want to see. I might do one more AMC thing, but like AMC is literally like this Thursday, so I don't know if I'm going to be able to get that out in time. But I will for sure get to silver and some of the gold problems. You guys let me know which ones you guys want to see. But other than that, that is all I got for you guys. Thank you guys for watching again, and see you guys next time.